Hello everyone, welcome to the series of concepts at Mathegination. I am sure you previously heard the word binomial. Now in this video, let's learn about this concept that what is mean by binomial, what is binomial expansion or binomial theorem, and how to expand the binomial formula. Okay, so let's first see what is mean by binomial. The word binomial consists of two words. The first one is bi and the second one is nomial. Bi means two. This is because binomial formula has two terms in it. The other word is nomial, which comes from the word polynomial, and this is because the formula when you open of the binomial expansion, you get the polynomial. So that's why the word contained by, which means two, because binomial formula has two terms, and the word nomial, which is come from polynomial, because when you open up the formula of binomial expansion of binomial theorem, you get a polynomial. Okay, now let's learn what is binomial formula. So let's learn first the general formula of binomial expansion. So binomial expansion of these two terms a and b. So remember I say the word bi means two because the binomial formula has two terms. The first term is a, the second term is b. In between we have plus sign and in the above we have the power n. So always remember in binomial expansion this n belongs to a whole number, right? And what we mean by whole number? We know whole numbers are 0, 1, 2, 3, and so on. So it means that in binomial theorem, the n is always a positive integer, i.e. the whole number. So n belongs to, let me write, n belongs to whole number, which is the set of these numbers. Now, how to expand this formula? So to expand this formula is really easy. The first thing is you have to do take this power with the n and give b the power 0. So this is the first term of the binomial expansion. Second, with the plus sign and take a this power n below and a power n minus 1. So what we did, we subtract 1 from the n. And then the power of b is, we start from 0, then the power of b is 1. Then we have again the n as it is. Now the power of a again comes down, so n minus 1. Then a, now again from n minus 1 subtract 1, so it means n minus 2, right? So from n minus 1 we subtract again 1, so what we got, n minus minus plus, so minus 2, so n minus 2, and then the power of b is the 0, 1, and now 2, and the next term is plus, I am writing it below. Now n minus 1 we already have. Now we take n minus 2 below, and then a, now we subtract again minus 1 from n minus 2, so we have n minus 2, then we subtract minus 1 again, so minus minus plus again, so it becomes n minus 3. So now a to the power is n minus 3, and the power of b is again 3, and it will continues until we got this sequence like n minus 1, n minus 2, and so on till 1 b raised to the power n. And the main thing is the denominators. which are the coefficients or what they are. So in the first term, take 0 factorial. So whatever the power of b you have in the term, take this term as a your 0 factorial. Now here the power of b is 1, so 1 factorial. In this term the power of b is 2, so 2 factorial. In this term power of b is 3, so 3 factorial. And in the end we have power of b is n, so n factorial. That's how we find out the formula, the expansion of any two terms. Now, you are curious that, okay, what about minus sign? So instead of plus, if we have minus in between, so the formula remains same. The only thing you have to notice is that from now you have to take plus and minus sign alternatively. So plus when the first term with the plus sign, the second term with the minus. So when we have minus a minus b raised to the power n, so the formula remains same, just the sign values is changed, and the first one is remains same, but is plus, second one is minus, third one plus, fourth one is minus. So you have to change the sign to negative for the even terms, right? And so on. Now, another thing, notice that always whenever you have this expansion, you can cancel out this factorial thing and got the nicer equation or polynomial. So you see now we have a polynomial, because what is polynomial? Polynomial is an algebraic expression. Polynomial is algebraic expression with positive positive powers. So you see that n is positive. So n minus 1, n minus 2, n minus 3 all are our positive numbers. Now, one thing, so if you learn more about polynomials and algebraic expression, we already have the video about this. Please check out our other videos as well. Now, right, so an b raised to the power is 0 is 1, 0 factorial is 1, so the first term is an plus the second term is n a n minus 1 b raised to the power 1, so on till the end. We have last thing, which is n factorial, and you can see above what, right, n multiplied by n minus 1 multiplied by n minus 2, and this thing is also n factorial, right? This thing is also n factorial, so we can cancel out n factorial to n factorial, right? Why this is n factorial? So you remember what is the factorial of 3? 3 into 2 into 1, right? What is the factorial of n then? The factorial of n is n minus 1, n minus 2 till 1. So you can see that the same thing is written here, n minus 1, n minus 2. All the things are multiplying until 1. So this is nothing but the n factorial. So we can cancel out, and then what we got as a last term, bn. So always, whenever you expand the polynomial expansions, binomial expansions, what you got? The first term is an, the second term is bn, right? And in between you have different terms. Okay, so whenever you open the formula of a binomial expansion, whatever power you have, the number of terms you got is n plus 1. What does it mean? So suppose you have to find a plus b to the power square. So when you open up this formula, you got a square plus 2ab plus b square, which are three terms. And this is not a coincidence. It always happen. Okay, to see this thing and to see the formula very clearly, let's see some examples. So let's take the binomial of power 2. So the formula of a plus b to the square. So we already know that a plus b to the square, the formula is a square plus 2ab plus b square. But where this formula come from, right? So this formula comes from the binomial expansion, and today you see how it comes, how it makes this formula. Okay, so let's see, we have a plus b to the power square, and we don't know what is the formula of this a plus b to the whole square. But as if we know the expansion of binomial, we can make formula of any power. A plus b go to the square, a plus b to the cube, a plus b to the power 4, and we will see in the example. So suppose we have a plus b to the square, right? And we know how to expand the polynomial, so let's expand it. Now the first thing is a to the power square, right? The second term, this 2, so b raised to the power 0, right? Now in the second term, we took 2 below b, sorry, not b, we have a, right? Write it correctly. A b to the power 0, 2 a, now 2 minus 1, b raised to the power 1, plus now 2, 2 minus 1, 1, we'll take 1, a raised to the power 0, and b. So now a2, again the main thing is 0 factorial, 1 factorial, and 2 factorial. So whatever power of b in the term, we got in the denominator the factorial of that term. Okay, so this is a square plus 2a, 2 minus 1 is 1b, 1 plus 2 factorial is 2, 2 and 2 cancel out, a raised to the power 0, 1, so b square. So what we got? A square plus 2ab plus b square, right? So as you know that it is the formula of a square plus 2ab plus b square is the formula of a plus b cubed to the square. Now take the formula of a plus b to the cube. Suppose you don't know what is the formula of a plus b to the cube, but since you know now the expansion of binomial expansion, how to expand the binomial theorem, so now you can easily make any formula, any formula. So let's make this formula a plus b to the power cube. So what you did, first a to the power 3, b to the power 0, plus now what we do, a3 below, come below, a3 minus 1. So what we did, subtract 1 from the power. So 3 minus 1 is 2, b to the power 1. Again plus, now 3 as it is, this 2 now, so the power of a always in the next step always come below. So now this 2, this become in below. Now a 2 minus 1 is, now again subtract, so 1, then b to the power 2, plus now 3 as it is, 2 as it is, this one comes down, a power 0, p 3. Now 0 factorial, 1 factorial, 2 factorial, 3 factorial. Okay, so a3, b0 is 1, 0 factorial is 1, a3 plus 3 a square b plus 2 to cancel out, 3 ab square plus 3 factorial, 3 factorial to the power 0, 1, now b cube. So a plus b to the cube is this. Now notice that since you know the expansion, you know the binomial expansion, you don't have to remember the formulas, right? Just you have to know what is binomial expansion, and you can expand any formula of any powers. One thing. Second thing is, if you want to make the formula for the negative term, so the only thing you want to add is, instead of plus, go with the minus for even terms. So first term plus, second minus, then plus. Here, if you want to the formula for minus, so first term plus, make second minus, third plus, this one, right? So the formula for the plus and for the minus is just same. The only expansion is the minus sign, which comes with the even numbers, even values, even terms. Right. Another thing to notice that you can see that this is a plus b to the power square. And when you open the formula, what you got? A square plus 2ab plus b square. So the power is 2. The term you got is 3. The formula, when you expand, it has 3 terms. Power is 2. Here you see the power is 3. But when you expand the formula, how many terms you got? 1, 2, 3, 4 terms. So you always got n plus 1 terms. So whatever power you have. So if you want to know, so let's see. So if you want to find a plus b to the power 5, right? So you already know that when you open it, you got 6 terms. First term always a5, say a last term with b5, and in middle you have 4 more terms. And how you got these terms? Just use the formula. So in total you got 6 terms. So this is binomial formula or binomial expansion, and in this video you learn how to expand them. So if you like the video, please like and subscribe our channel Mathegination. See you in the next video. Bye bye.